In this lesson, we'll cover how to find distance on a coordinate plane using Pythagorean theorem. So let's start with the investigation in number 1. It says, use the diagram below to answer the following questions. And the first one is, what are the coordinates of A and C? So point A is over here. That looks like it's at -3, 4. And then point B is, C is over here. And it looks like it's at 1, 2, 3, 4, 5. And then also up 4. And then it says, what is the length, or count the length of the line AC? So this is literally just the number of squares. We're counting hops here. So 1, 2, 3, 4, 5, 6, 7, 8 is the length. Okay. What are the coordinates of C and B? Well, we've already found C. That's the same as this one. So that's going to be 5, 4. And then B, it's down at the bottom. And that's over 5 as well, but this time down 2, or -2. And so if we count that length, we've got 1, 2, 3, 4, 5, 6. Okay, draw a line. I think that should say connecting A to B. Whoops. So we're going to draw this diagonal line going from A to B. And then what kind of triangle did we just create? Well, if we've got vertical and horizontal lines, we have just created a right triangle. Or a right triangle. Get it? Just kidding. All right. What theorem can be used to find the length of the hypotenuse of a right triangle if you know the length of the two legs? And I'm sure most of you actually remember this. Good old Pythagorean theorem. A squared plus B squared equals C squared. And what we just drew in here is the hypotenuse of the triangle, and that's where we plug it in the Pythagorean theorem. It has to be the C squared. So now we're going to use this theorem to help us find the length of AB. Now the reason we can't just sit here and go, okay, this is 1, 2, 3, 4, 5, 6. Like, it'd be great if we could just count it that way, but we can't count diagonal length on a graph. We can, however, count vertical and horizontal length that goes perfectly with the grid. So because of that, we can use Pythagorean theorem to find those diagonal lengths we can't count. So we're going to take the two leg lengths we found over here. We said that that top one was 8 and that our vertical one was 6. So those are A and B. All right. And so that's going to be 8 times 8 plus 6 times 6. And I think that's a nice one, actually. And then remember to actually solve for something being squared. Like, this isn't our answer here. We have to square root to undo the square step. And 100 is a perfect square, so we get a whole number. But oftentimes you will get a decimal. All right, so that means that the hypotenuse, or AB, is equal to 10. Now this is kind of like our warm-up investigation here. What you're typically going to see is something more like number 2, where you just start with a diagonal line and you're asked to find the distance. So when you do this, what we're going to do is build in our own legs of a right triangle so that we can then find that, quote, hypotenuse length. Ooh, can't say that word. All right, so on the diagram seen left, create a right triangle with a horizontal leg, vertical leg, and hypotenuse. So when you draw your legs, right, you're not just making any triangle. It has to have very specific types of legs. So you can only draw going up and down or side to side at each of these vertices. Okay, and so because of that, you can actually draw two different triangles. You could draw a right triangle above, or you could draw a right triangle below. And that part is up to you. But it has to be with the coordinate grid. You cannot draw other diagonal lines. That would not make your life any better. So it's up to you which type you want to draw for this particular example. I'm going to draw the one above, but it doesn't affect your answer. So I've drawn in a right triangle. I'm labeling that new corner I just made C. That was number 2. Then it says, is this the only right triangle? Well, I think we must have jumped ahead there, because no. You can draw one, if you have your line like this, you could draw it in above or below. So basically, if you made a rectangle. Then they want you to find AC and CB. So find your two leg lengths. So these we can just count since they go with the grid. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7. Awesome. So AC equals 5, CB equals 7. And then use that to find the length of AB. So we're going to have 5 squared plus 7 squared equals AB squared. So 25 plus 49. And I'm getting 74. So when I square root both sides this time, it's not going to be a perfect square because there's nothing times itself that gives me 74. So you have two options. You can either say that if you want the exact answer, we can say AB equals square root 74. Okay? Or you can tell me the estimated answer, and usually just one decimal place is fine. And in this case, it's 8.6. So the square root version is the exact, and then the decimal version is the estimated. Awesome. So moving on, let's actually just practice this the way you'll probably see it. Typically, you're just going to be given 2 points. You might not even be given a grid, so you can always ask for graph paper when needed. So let's do problem 1. We need to plot our points correctly first. So -2, 5 would be right around there. And 3, 5 will be right around here. And so this one's actually really nice. Here's the thing, if I have a horizontal or vertical line, there's no need for me to actually draw in a triangle, right? Because I already have a line going with the grid, and so we can just count that length. So that one's just going to be 1, 2, 3, 4, 5. Done. No fancy Pythagorean theorem needed. All right, for the next one, we have 3, 5, and 3, 1. Oh, they're being nice to us, aren't they? So again, since this is a vertical line, I don't need to draw in a triangle. I can just count that distance itself, which should be 1, 2, 3, 4. I think I see where this is going to go. And of course, they want -2, 5, and 3, 1. And they've set us up nicely so that we already know our two legs. So 5 and 4. So we're going to use those with our Pythagorean theorem. 5 squared and 4 squared. And we're going to add it. And that's going to give us that distance. So you can put D for distance. I just keep a C like Pythagorean theorem normally is, but it doesn't matter. So that's going to give me 25 plus 16. Let's see. 41 is not particularly pretty. So when I square root both sides, it's not going to give me a perfect square. So I can either write that C equals square root 41 or estimates to 6.4. Awesome. All right, so let's go down here. So this time it's not going to lead us to that. We're going to have to kind of draw in our triangle ourselves. So on number 4, we're drawing -6, 2 as a point and 4, 8 as a point. And I would go ahead and just connect that once you have your 2 points. And now what we're going to do is draw in a triangle. You can draw it above or below. We'll go below this time since last time we went above, but it doesn't matter. Okay, so now we're going to count those leg lengths. This one here, let's see, it would be 6 to go to 0, and then 4 more, so 6 plus 4 is 10. And then going up and down, it's at 8 and 2, so that's a difference of 6. All right, 10 squared plus 6 squared equals C squared. So that's going to be 100 plus 36. So 136. Square root that, and it's not pretty. So again, exact would just be this, and then I can use my calculator to get a estimated answer of 11.66, which I'm going to round to 7. Bam. All right, we're just going to keep rocking and rolling here. So the next one, we have a point at 0, 7, and a point at negative 10, 3. I'm going to connect those points. Let's draw our triangle above this time, just to keep things interesting. All right, so going up and down, we have a point at 3 and at 7. So that's a vertical change of 4. And then side to side, we have something at negative 10 and something at 0. So that's 10 apart. So 16 plus 100. Square root, not pretty. So we could also estimate it to be 10 point something. I'm not sure. 10.8. Whoop whoop. And then down at the bottom, this is kind of like a vocabulary word. It says if two line segments have the same distance, then they are what we call congruent. And that's a fancy word for equal length. Okay, so we're going to start working with shapes this week. And one of the properties of shapes that we'll look for is if they have 4 equal sides or pairs of equal side lengths. And so this is the way we'll be able to do it. All right, well, this concludes your video lesson on distance on a coordinate plane.